I'd like to introduce Sonali Singh from Aspen OptiPlant 3D.
Thank you, Bill. And thank you to all the SPED members and the SPED community and Catherine for helping set this up. I really appreciate the opportunity to speak to all of you today and welcome you to today's session. So as Bill said, I'm Sonali Singh. The company is now Aspen Technology. Our original company, OptiPlant, was acquired by Aspen Technology about 4.5 years ago. So now Aspen OptiPlant 3D is a product within Aspen Technology. So today, let me go ahead and move forward here. I'm going to spend about 45 minutes and I want to talk about how Aspen OptiPlant helps you with conceptual 3D models, with auto layout, and with automatic pipe routing. So we're going to cover kind of the full scope here today. And what I wanted to do first is maybe just talk about how does it help on pre-feed and feed projects, and then I'll get into some demos of how it actually works and kind of talk through that. We have left time at the end for Q&A, and as Catherine mentioned, you can go ahead and put questions in the chat. I'm also very open to if you guys have questions along the way and you just want to speak up or raise your hand. I'm happy to keep this more interactive. I know we've got a very senior group here. So I want to, get into the conversation as soon as possible. So at Aspen Technology, I am the Vice President of Product Management for what we call our Performance Engineering Suite. And what we offer is a very unique connected solution for your pre-feed and feed stage projects. We also offer solutions for operations, but we're going to focus today on pre-feed and feed stage projects. And as you know, these projects have multiple disciplines and multiple engineers that are involved. Oftentimes, they're very sequential in nature. So, you're waiting to get P&IDs, you're waiting to get simulation data, maybe a sized equipment list. There's a lot of waiting. These types of projects can also be very fast-paced. And when you've got these short schedules on these projects, there's often very little time to optimize, right? To really get to the best design or a better design. And also, I think what I hear from many of our customers today is, there's a large variation in the level of expertise and experience. So the designs and the results are not always consistent with best practices or with, standards that maybe the company has established. So our goal is really to drive from like the sequential approach to a little bit more of a simultaneous concurrent approach to help with the optimization and to drive to more consistency. So we take all the different engineers and designers and people involved on the project. And what we offer is this connected and concurrent solution. And when I say solution, what that basically means is the ability for the different software products to work together. So the advantage here, I think, that we have at Aspen Tech, or what's unique is, generally most things start with the actual process simulation, whether, let's say that's in HYSYS or Aspen Plus. And what we have is this connection and ability to work along with the process engineer for the piping designer, because there's this connection from HYSYS and Aspen Plus to Aspen OptiPlant 3D. The other key person involved is usually the cost estimator, especially at this stage of the project, as you're trying to come up with the best CapEx cost and really get the feed to an FID stage and get into detailed design. So what we have is Aspen Capital Cost Estimator, which is also connected to OptiPlant, and you can work simultaneously between the cost estimator and the piping designer or the layout engineer. So, the ability for these people to work together along with mechanical has proven to really be one of the fastest ways to get through a pre-feed or feed stage project, but also gives you the ability to come up with some better designs, to come up with more options, and to drive some greater level of accuracy on the cost estimate so that you don't see as many changes in detailed design. I do want to mention that we also offer a product called OptiRouter. OptiRouter is a plugin on top of Hexagon Smart 3D, as well as on top of Aviva E3D. So the opportunity there is it lets you apply this AI-driven automatic pipe routing inside of your Smart 3D and E3D models. I'm not going to spend a lot of time on that today in the 45 minutes we have, but maybe that's an opportunity of a follow-up webinar sometime in the future. So this is our unique solution, but today I'm going to focus in on this middle piece right here, on conceptual 3D and on OptiPlant. Okay, so first, for those of you, I see many new names here as well. I think some of you maybe have seen this before. Aspen OptiPlant 3D has been in the market for over 12 years now. It is a proven product in the market. What we really focus on is automation and very quick development of a conceptual 3D model. So it's not a detailed design model. It is a conceptual 3D model. So the key features here, if we start at the top, one of the newest things we've introduced that we're excited about is an AI-based automatic equipment layout. This is 3D equipment layout. I'm going to show you that later today. But we also have this ability for you to, go through and build out the equipment layout yourself, leveraging 3D parametric equipment and structures. It's just a much faster way to build out the model than if you were building it out in E3D or S3D. From an auto routing perspective, what we have is 3D interference-free auto routing of pipe, as well as of cable tray and conduit. Today, I'm going to show you, some demos of the piping. Just interest of time, I'm not showing the cable tray, but one of the reasons we included cable tray and conduit also is what we're trying to drive to is a multi-discipline 3D model so that at the early stage, you can really validate the layout and having more, more sizes, more disciplines in the model can help increase the accuracy of that cost estimate. So from OptiPlant, you can generate all the key deliverables that you need, like 2D plot plans, 3D layout, your line list, your bulk quantities for pipe and steel. And then we have some additional capabilities that I'll talk about around like modularization and construction planning as well. The integration or this connectivity with simulation, with cost estimating, and with some of the other tools really helps improve the speed of how you can get through this modeling process. And I think it helps with the collaboration that you have to do with, other members on the project team. And of course, one of the key things is the handover to detailed design. So as the project progresses and it's going to go forward, we ensure that the piping and the equipment will go forward into both S3D as well as E3D. There's some other opportunities with some of the other tools that you might be using, like CADWorks and Plant 3D and so forth. But our goal has always been interoperability and making sure that that data carries forward so it helps downstream as well. Okay, so first I just want to talk about, how has OptiPlant helped? with cost estimating and with pipe routing, and just talk through a couple examples so you have that kind of in the back of your mind before we get into the demos. And what you see here are images from, projects that our customers have executed over the years. So it's been used as early as, FEL1 feasibility studies. A lot of our owner operator customers use OptiPlant very early just to look at, is it even going to fit in the real estate that they have, in the site that they're trying to build on, especially say for brownfield projects. Just trying to get a high level 3D visual of what the scope of the process is going to be. At a very high level, it can support class 5 estimates that you might be doing based on, historical data and things like that. But it also, OptiPlant, because it can ingest data from like other sources, old 3D models and things like that. You can also reference or you can also use reference project data. And that's kind of a quick way at the feasibility stage to start to study, site planning. Is it going to fit? What's the scope? Do we want to move forward to a pre-feed? When you get to a pre-feed stage, that's what I'm going to call here is FEL2. This is an example of an LPG project that was done by one of our customers. And for this LPG unit, they actually developed 5 different layouts. There was an existing pipe rack and an existing flare that they had to leverage, but they wanted to look at kind of optimally how could they develop the layout as well as support the cost estimate. So by using OptiPlan, and in this case they also use the Aspen capital cost estimator for cost estimating, you went through 5 different layouts. That's what we sort of refer to as optioneering or engineering multiple options. They went through, created the layout, auto-routed the pipe, compared things like module versus stick-built construction, the quantity of pipe, the quantity of steel, and then picked the best layout to move forward to the feed stage. So it did support a class 4 estimate, and all of this was done in about 6 weeks. And that, time frame for this EPC company was about 50% of what they would have done with their kind of manual or alternative approaches, and they would not have been able to come up with the 5 different options to compare. So I think, it's something that I've always heard from our customers, is that ability to really be able to compare, options and quantities, as well as piping design. Is the pipe rack big enough? Do you have enough levels? Get as much piping in there to confirm that, especially at this stage, becomes really important. So that's for pre-feed. And then when you get to the feed stage, of course, the models are going to get a little bit more detailed. We're going to put more piping into the model. In pre-feed, we've traditionally seen like 6-inch or 8-inch and above pipe in the model. Here, when you get to feed, you're going to do 2-inch and above. And it's automatic routing. So even if you want to do small bore, which, normally comes later, there's an opportunity to put that into the model as well much earlier. So just a couple of examples here. This one is a public example. This was the Northwest Upgrader refinery up in Calgary a long time ago. And OptiPlant was used for all the site planning as well as all of the unit modeling, doing all the pipe routing in there to establish the best site plan and then generate cost estimates. And then before the model was converted to a combination of PDS and Smart 3D. I also wanted to highlight here, brownfield, right? Feed stage projects where you may have a laser scan model. OptiPlant will import that laser scan model, and then you can do your automatic pipe routing around the laser scan area and look at new equipment or a new module maybe that you're putting in place there. So, OptiPlant can be used in the feed stage. You can really start to kind of capture some of those design issues very early, support a class 3 estimate, and again, really be able to just put more into the model at the feed stage. And then for detailed design, and this would be the early stages of detailed design, I would say up to like 30% model review, maybe, 40% model review, where you can leverage OptiRouter inside of S3D for many different use cases, maybe just for auto routing your small bore pipe around what's already been manually modeled. Sometimes, just trying to establish space and pipe racks, and if there's enough space in there. So lots of different use cases there as well. So just wanted to kind of highlight that, it can be used at multiple stages of the project up to detailed design, and then kind of some of the value that it's brought to these projects. Okay, so now let's talk about how does OptiPlant work, and I will show you some things. Just in terms of sort of I'll call it like a feature list of, OptiPlant and everything it offers today. The goal again is this optioneering, right? How quickly can you come up with multiple options and really be able to do a compare and contrast between them? But from a feature set, we have automatic layout of 3D equipment. We have also a module for automated schematics. So I don't want to call it a PFD or a PNID, but what it will do is based on the equipment and the pipe in the model, it'll help you generate some high-level schematics that look like PFDs. So you've got kind of a paper deliverable, a line drawing, a different view to validate what's actually in the model. Of course, we've got the 3D pipe and 3D cable tray and conduit auto routing. I'm going to show you that. For steel, it's primarily the ability to quickly model pipe racks, modular structures, structural frame buildings, etc. Equipment spacing. This is very unique to OptiPlant, and can be really valuable when you're trying to optimize your real estate and really being able to look at how can you shrink the footprint of the layout. So it gives you some visual on how to check that you're not violating spacing criteria. We offer PIP spacing standards built in, but they're editable and they're changeable, so you can change them as you need to. And then from a piping perspective, there is some basic algorithms for pipe sizing early on if you don't have a pipe size. We have some piping assemblies built in for control stations around pumps, around heat exchangers, calculation of expansion loops on the pipe rack, et cetera. So a lot of little kind of piping analytics, I'd say, built in there. It will also automatically build 3D foundations into the model based on the weights and based on the soil criteria. So it's just another element for evaluation purposes to study the layout. And then modularization. These days, a lot of projects are going to modular construction. So just being able to design modular, have the pipe quantities and auto routing take into account modules. This has been a key focus as well. The other main thing that I think the value of OptiPlant is the amount of data sources you can pull in as a starting point, so you're never starting from scratch, and then all the places the data can go. Again, today, just because of time, we won't talk through all of this. I'm happy, to follow up with anyone who wants to talk about that further. But today, what I will show briefly is a video of how we can convert the OptiPlant model to Hexagon Smart 3D. Okay, so Generative AI-based auto layout. This is a new capability that we added a few months ago now. And basically, the way that it works is you provide your sized equipment list, you provide the real estate, the plot plan area. You will need to model in the pipe racks. So pipe racks are still going to be placed manually. And then you're going to provide kind of an initial connectivity list or line list. Based on that and the equipment that's in the equipment list, the AI will basically go through and generate 3 options for you. You can review the options and then choose one as the starting point. And one of the key things I want to point out here is that's the objective. The objective here is just that it's a starting point for you. It's not a final layout. You're not, ready to go from here. But it's a really quick way to get a starting point of the model and also leverage that optioneering because you can change the real estate, you can change equipment sizes, you can change whether you want modular or stick built and just keep generating options and saving them. There's a version control built in. And then you can decide, which options to really build out and explore. And it does work for both brownfield and greenfield. So in a brownfield case, you would basically have frozen equipment as part of the existing layout, and then it'll place the new equipment around what's already in place or what's already on site. So I'm going to show you a video here. Just want to make sure that the volumes are off. Okay. So we're going to start with, let's say, a HYSYS or Aspen Plus data set. And then here is OptiPlant. And this is the auto layout settings here. So what we've set is a 200 by 200 feet plot area. Again, you would define that. You can start small and then, expand from there. We've built out 2 pipe racks, an east-west pipe rack, a north-south pipe rack, and a little modular structure here on the top right. And then what we're providing is a list of equipment and that line list. And we're telling the auto layout to consider the existing pipe racks in the model as well as the structures that are there. And these are the kind of constraints or parameters you can play with, and you can say, well, don't consider the platform and, tell me what the layout would look like. So from here, once you kind of provide this minimum input, you can save those settings and you would go to generate layout. And it takes a few minutes, about 5 minutes, for it to go through and generate 3 options for you. The time is pretty fast, even if you get to larger number of equipment, as well as larger areas. It's still, in that kind of 5-minute range there. I'm going to just pause here for a second. So these are the 3 options that it's come up with. And each option is sort of prioritizing something different. Okay, so in this option 1, what it's going to prioritize is connectivity. It's what we call community. So it's trying to keep the equipment that's part of like a unit operations, that's part of that block flow as close together as possible. So it's trying to optimize the spacing that way. For the third option here, it's going to look at size. So it's taking into account the size of the equipment and giving priority to the larger equipment sizes. And then in the middle case, it's trying to optimize for modularization and putting things within, it's connected as well as within modules. With each of these options, there's this little binocular up here, and you can use that binocular to sort of investigate the model. It's going to highlight in Halo for you any possible warnings or violations. So it may not be able to, completely fix all the spacing issues for you, but it's going to highlight them for you. And then you can choose which model you want to start with as your base model and go from there. So you're going to, let's say, proceed with option one. Option one then becomes your base model. It's just a good way to get started. And then you can make changes in here to moving the equipment around, resizing, putting them inside of a structure, etc. Make all those changes, and then you'd use that same line list to automatically route the pipe. And the other option here is you could load each version, route the pipe, compare it that way, and see what you're getting in terms of, like success rate of the auto routing will tell you, okay, there's enough room really for all the piping. It's going to work out okay. Or if you get a lot of failures, they'll show up in red. Like you see this pipe in red, it means something went wrong. There's an interference there somewhere. So, the more red pipes that are in the model kind of gives you an indication that there may not be enough spacing or there's something in the layout that's causing the pipe to not route. So the key here is the speed and this ability to kind of quickly automatically generate a bunch of layouts, route them, compare them, and then kind of decide which one you want to proceed with. I get it, it's a very different workflow than what we're used to. But just looking ahead and all the things we're all doing these days with AI, we feel like this is definitely the direction that we're going to go here. Okay, so now the next demo part I want to show you is if you were not using the auto layout, right? Let's assume you're just starting from scratch. It's a blank sheet. You don't want to use the AI auto layout. You've got a good idea about what your layout should be. What we have here on the side is those parametric models I mentioned for equipment, for structures, everything sort of form driven for you to be able to, import or set your data, like for example, here on the pipe rack, just the width of the rack, the number of levels. You can also choose member sizing that's built in, all the different member sizes, so it'll automatically do the sizing for you. So this would be more the manual modeling approach, which also is very quick because it's less data than what you'd have to put into a form, say in E3D or S3D. And the key thing is also the change, right? Being able to then go back in and, reduce the number of bays or change the direction of the pipe rack. Those things are easy. With the equipment, minimum data, just diameter of the tube, length of the shell, and this category here is where you would set that PIP equipment category so it knows to check that as part of the spacing check that you might do after the layout has been set up. Very simple copy move capability. So build one heat exchanger, copy the other two, and get them into the model. So one of the things we focused on here is also options, right? Depending on what information you have, a different workflow might be best. You can reference in 2D drawings, 2D plot plans that you already have, and then that becomes an easy way to start to go through and, pick an equipment off the library and place it in here. You can also import equipment through Excel. This is what we have in place with ACCE, with Aspen Capital Cost Estimator. So if your estimator is already built out their project, they've got a list of equipment, you can pull that sized equipment data in here and bring it in through Excel. I want to just show the spacing here. So with equipment spacing, let's say you take that pump and you're going to try to move it a little bit closer. This is where you set the category of the pump. And then we've got a tower there, a column, the stripper column. We're going to set a category for the column. And, there's some minimum spacing. This is a simple example. You take the pump, you try to move it closer to the tower. It's going to tell you you're now violating the spacing rules, right? You can also see this visually. So, which is kind of nice because then you can see how close can you bring it and not be able to violate the spacing criteria that's set in there. So there's some really simple tools here. One to learn maybe how to build a layout, but also to validate that the layout has followed the standards and the rules. So that's if you were going to go through and not use auto layout and manually build out your layout. So now let's look at the piping. Sorry, I'm just trying to make it go forward here. All right, so for piping, the main input is a line list. And I just wanted to, show the basics of how this works. Admittedly, this is the part that takes all our users the longest because one, you're waiting to get complete data set, could be off of PFD, could be off of PNIDs. So we've again tried to offer multiple options of how to build this out. So we do offer a simple template where you can go through and, add the fluid code, sequence number, size, spec, and tos and froms, right? You're saying, where does the pipe start? Where does the pipe end? And one of the unique things that we offer are these rule-based nozzles. So you don't have to build nozzles out on the equipment. None of the equipment I've showed you so far have you had to put nozzles on them. Here, you're just sort of, I'm going to pause here for a second. You're just choosing, tube side, shell side, pump suction, pump discharge, and it's going to automatically put nozzles on the equipment for you. That has been a true time saver. A lot of our users have shared that with us. Besides building it out manually, you can also import from Excel. So if you do have a smart plant PNID, for example, you could pull that in via Excel into here. If another group has given you a line list in Excel, you could import that in here. But and the schematic creator that I mentioned earlier is another way to consider this. But so far today, I don't have that to show you. But again, that's something we can follow up with. So once you have the line list, you're going to go through and just run the batch. There's different configurations here. You can run it fully interference-free, which is what we're doing here, or you can run it without interference check. It'll run faster. It'll just validate that your input is correct and, get things into the model. Once the pipe has routed, pause here for a second. Actually, so in this model, you can see it did also auto route a cable tray system that's there on the top level. So you're starting to see, multiple disciplines in the same model. The auto routing here, this was about 68 lines, I think. Again, that it probably runs in 3 to 5 minutes. And as you add more lines and the models get bigger, it will take more time. But the way our auto routing algorithm works is it's really focused on accuracy and running the pipe many, many times and then choosing the best one. So that's where, the algorithm maybe is it's very different from the others you might be seeing. But the focus here is on like a interference-free, accurate result. Just a couple of things we're going to show you. It'll automatically build nozzles for the connections, and just what's nice there is then you can move the nozzles around. So when you rerun the batch, it'll route to a new location based on where you've decided to put the nozzle. And let's see here. We're going to just show you here an example of a piping assembly. So for example, a control valve station, you can put it after the fact, after the pipe has been run in the batch. It will modify the center line. And, you're just kind of choosing different control valve station configurations, horizontal, vertical, left side or right sided configuration. It kind of just sets kind of a box here for you to visualize. You can move it around, decide exactly where in the route you want that control valve station to go, and then it'll update it to include it in there. So it's not part of the auto routing. This is something that the user would set, but again, it's pre-configured as a template, so it's sort of easy enough for you to move it around and really control where it's going to go. Okay, so I want to show you one more example of the pipe routing. So in this model, I just wanted to show something that had a little bit more in terms of piping. So same approach. We've got a line list here. I think this one has 145 pipes. And as this routes, what I wanted to show, of course, is also it can do underground piping. So you're going to see like the underwater firewater loop, underground firewater loop come in. We've focused in kind of on that integration between underground piping, above ground, all different sizes. So it knows to run it in a sequence based on size, material, temperature, whether it's a header or a branch. And then as it goes through, I don't recommend using OptiPlant for like a valve count or a flange count. You don't need to insert every single valve in here. You would really focus in on the main piping segment, making sure that there is enough room there for all your inline components and so forth, and that it's a good, it's good in terms of quantity, but it's also good enough in terms of transferring it forward as a starting point for detailed design. But detailed design is really where you're going to put in, all your instruments, your valving, et cetera. That's the place to do that. This is to generate, a good interference-free pipe route. There's also rules for like air cooler, Christmas tree configurations, for heat exchangers, whether they're stacked or not, how to put all the piping in there and the assemblies around heat exchangers and pumps as well. All right. So from here, the next one, I just a quick look at the fact that, once whatever model you're in, once you've got the piping in the model, sending this to the cost estimators and to an estimating tool is fully automated from OptiPlant. And you can control, oftentimes with, let's say, K-Base or Aspen Capital Cost Estimator, the piping team will only send the piping on the pipe racks. And let me pause this here. On the pipe racks to support the estimate, because the cost estimating team may use ACCE for like the unit piping. If you're doing modules, though, you may want to send the pipe quantities from specific modules over to ACCE. So the interface that we have that publishes to ACCE will help you kind of pick and choose what part of your piping you want to transfer over to estimating. And then this is just a view of the Aspen Capital Cost Estimator where, we've got the interface to import the data directly in there. So again, it's that, hopefully no one's waiting for each other and you can kind of send things back and forth, allows you to make the changes and still be able to send it forward. The pipe from OptiPlant comes into ACCE as individual components with the quantities. You can kind of divide them all the different ways. ACCE sets that up. So it's just a much faster way to shorten that part of the workflow as well. All right. And then the last thing here I wanted to show was around the integration to Smart 3D. So again, the piping, the equipment, things you've modeled here in OptiPlant will go forward I guess the new name now is Octave Smart 3D. And currently we're leveraging XM plant converter there, but we will be updating this to the S3D API as well. So, I just wanted to show that nothing is kind of, dead in the water at the end of OptiPlant. Once you've generated those pipe center lines, all of that would go forward into Hexagon Smart 3D as well. And this is just showing not just the piping, of course, but the equipment and the steel do also go forward. Right now, we don't have the electrical, the cable tray, or the conduit going forward to Smart 3D or to E3D. All right. So hopefully I've shown kind of quickly how OptiPlant has been helping our customers with their projects kind of across, multiple phases. And, I wanted to show and highlight some of the key features. Of course, we didn't go through all of them today, but to give you a view that, our pipe routing really focuses on, one, the interference, validating the layout, but also has a lot of this capability built in terms of the assemblies, in terms of the analytics, so that you can kind of run these iterations quickly and get, accuracy out of the results as well. So with that, I saw that there were lots of questions in the chat, and I know Sergio Hernandez from Aspen Tech is here as well, and I think he's been helping answer a lot of these questions. So I'm going to try to look here and see what questions maybe have not gotten answered, or if anyone has any questions now that they want to ask, please feel free to unmute and ask. Maybe, Sergio, I can check with you. Are there any questions that did not get answered that we need to?
No, I think we're good. The last question submitted was highlighting the role of Aspen automatic equipment sizing and design. You might want to speak to that.
Yeah, it's a great question. And, the great thing is we actually have multiple tools available within the Aspen suite to help with equipment sizing and design. So the HYSYS and Aspen Plus do design for columns and for heat exchangers. And then we have, as part of Aspen Capital Cost Estimator, as well as another tool we have called APEA, that they would additionally size the remaining vessels, your pumps, etc. So as you use this workflow, that's one of the advantages, is as the data gets to OptiPlant, it's already been sized for the equipment, which at least at a initial level, it may not be a rigorous sizing, but a high level conceptual sizing has been done. So it just helps users get started faster. And again, they're not waiting, for mechanical to do that equipment sizing. So we already have that available, and part of the direction we're going is to make equipment sizing much more complete and much easier to access directly from OptiPlant as well. I see a question of, have you worked with Fluor on any projects? So Fluor is one of our customers. They've been using OptiPlant for the last 8 years on multiple projects. So yes, we work with them routinely, and they've used it, quite a bit. And as you know, Fluor is also big on their modularization technology and approach, and they heavily rely on OptiPlant to help them with the modularization studies. I see a question on what spec standards is OptiPlant using for sizing and spacing. So for equipment sizing, there's a combination of, using like API standards and so forth, but we also have algorithms built in for conceptual sizing of equipment. For spacing, what comes out of the box in OptiPlant is the PIP spacing guideline. But it is editable. So, if you've got other standards like CSI that you want to follow, or if you've got changes, we have a lot of our customers changing or modifying these standards, you can do that as well. So for brownfield designs, the question is, how do you handle tie-ins, demolitions, scans for backgrounds and interference? So OptiPlant will read in a laser scan model in the format of E57. So you can insert in or reference in a laser scan model. It will take it into account for interference. As we all know from these laser scan models, some of it depends on the density of the scan and how accurate it is and so forth, how clean it can be. So I'm not going to say it's completely interference free, but it does reference it and tries to check for interference against the scan. Tie-ins could be handled in multiple ways. One of the things we offer in OptiPlant is just like a box connection. So you could if you've got the tie-ins in like an Excel file, what we recommend is to import it in as little boxes at each of those tie-in connections. And then in the line list, you're kind of just auto routing to that tie-in point, and that will get it into the model. The next question I see is the auto-generated pipe. Is it just a 3D representation, or is there a database associated with it? Yeah, so there's a lot of data associated behind that 3D pipe that you're seeing, and that's what makes it possible for us to convert our 3D representation to, say, Hexagon Smart 3D or Aviva E3D representation. It's not an actual database today. You don't need SQL or any other database to get loaded. We just have the data stored in different formats like XML and Excel. But lots of data associated to that 3D pipe. And like I said, that's what makes it easy for us to then convert it to other systems as well.
Thank you very much for coming.